To recap, basically, we used all of the electrons from these electron carriers, carried them through. Some of them joined the water, but most of them went up and joined the high concentration area that makes energy. This is probably the hardest part to explain, but I think I can keep it very simple if I just say this. This embedded protein is called ATP synthase, and through the energy of all these hydrogen ions, it becomes powered, as if it was plugged in, I guess you could say. And ADP goes through it, grabs a phosphate in there, and makes ATP. This is possible because there's like a fan in there, fanning around phosphate, so that when ADP goes in, a chemical reaction can occur because they're so close together that they'll become ATP. I'm not a genius, I don't know how that happens, but I do know that it becomes ATP after it goes from there because the phosphates are being fanned around. And that, my friends, is chemosis. If you don't understand exactly how this works, I'll just show you a little illustration. ADP is basically some kind of molecule. I don't know what the black stuff is. It just doesn't really matter right now for this explanation. And it has 2 phosphates on its tail. In order for ADP to become ATP, it just needs 1 more phosphate. Pretty simple, right? So yeah, that's oxidative phosphorylation, which includes the electron transport chain and chemosis. Don't think that you can get away with just calling it the electron transport chain. You might be able to, but the whole thing is oxidative phosphorylation.